Hello everyone, this is Santhosh Kumar. Welcome to LIPS Research. We craft comfortable, international research education. Today we are going to see about aircraft pressurization system. A system which ensures the comfort and safety of crew and passengers by controlling the cabin pressure and the exchange of air from the inside of the aircraft to the outside. Pressurizing an aircraft's cabin has multiple benefits. There are four primary goals to keep a comfortable and safe cabin for passengers: maintaining temperature, humidity, air circulation, and cabin pressure. Most pressurized cabins are designed for aircraft operating at service ceilings between 25,000 to 50,000 feet. Inside these aircraft, the pressure of the cabin generally falls somewhere between 6,000 to 8,000 feet in cruise flight at high altitudes. Here are a few important benefits pressurization provides. Oxygen masks don't need to be worn. Low risk of decompression sickness. Less noise and vibration. Better control of temperature. Better air ventilation. Fewer trapped gas problems. Pressurizing system components. Heat exchanger. Used to cool the hot pressurized air to a usable temperature. Outflow valve. Primary cabin pressure control, regulates the amount of pressurized air that is allowed to exit the cabin. Safety valve, positive pressure relief valve. Prevents cabin overpressurization by opening automatically at a predetermined pressure. Negative pressure relief valve. Prevents cabin pressure from going below that of the ambient air. Dump valve. Releases all cabin pressure when aircraft lands. Often controlled by landing gear squat switch. First of all, we all need to know that how aircraft cabin get its pressurized air. Let's see now. Ambient air is introduced into a compressor, which is usually the airplane's engine. As the air is compressed, it heats up rapidly. This heated air is sent through a cooling unit, like a fuel air heat exchanger. Through ducting, this air is then introduced into the cabin. A series of overflow or outflow valves regulate how quickly air is released from the cabin. Air comes into the cabin quicker than it's released, creating a high-pressure cabin environment. The combined outside air, 50%, and filtered air, 50%, is ducted to the cabin and distributed through overhead outlets. Inside the cabin, the air flows in a circular pattern. About half of the air exiting the cabin is exhausted from the airplane through an outflow valve. The other half is drawn by fans through special filters under the cabin floor to be filtered again. The airflow is continuous and is used for maintaining a comfortable cabin temperature and pressure. The opening of outflow valve can be controlled by pilot in order to maintain the suitable pressure. Before we go to the conclusion, we will see an interesting fact. New aircraft lower the bar, in a good way. The Boeing 787 and Airbus A350 are two great examples showing improvements being made to traditional pressurization systems. While the overall concept of pressurization in commercial aircraft hasn't changed all that much in the past 50 years, the cabin altitudes have. Both of these aircraft are rated to a maximum cabin pressure of 6,000 feet. That's substantially better than the 7,500 to 8,500 feet you'll find in older jets. On long flights, this prevents passengers from experiencing negative health effects from high-altitude environments. even helping to reduce the impact of jet lag. Thank you for watching with Lips Research.